This week at NASA.
Things are looking good. Coming up on entry. Vehicle reports entry interface. We are beginning to feel the atmosphere as we go in here. It is reporting that we are seeing G's on the order of 11 to 12 Earth G's. Bank reversal 2 is starting. We are now getting telemetry from Odyssey. We should have parachute deploy around Mach 1.7. The parachute is deployed. We are decelerating. Feed chill has separated. We're found the ground. We're down to 90 meters per second at an altitude of 6.5 kilometers descending. Standing by for back shell separation. We are in powered flight. We're at an altitude of 1 kilometer descending. Standing by for sky crane. Sky crane has started.
Signal to us, you remain strong.
Touchdown confirmed. We're safe on Mars.
We got thumbnails.
The interest and reaction generated worldwide by Curiosity's trek to and landing on the red planet has been phenomenal. People in New York City's Times Square watched a giant screen and listened on Third Rock Radio to NASA Television's coverage of the vehicle's 7-minute, 13,000 to 0 miles per hour plunge to the surface of Mars. NASA TV also had more than 1.2 million people watching on nasa.gov. That's twice the record set for the recent transit of Venus. The NASA website even made available a map to which organizations were able to post locations of viewing events around the globe. Of course, the prime hosts were NASA centers.
It's hard to send somebody to Mars, and hopefully we can do that one day, but you certainly want to know about Mars before you send someone there.
NASA planetary scientist Kelly Fast of NASA headquarters brought Curiosity's landing and mission into focus for visitors at a community festival in Palmdale, California, near Dryden Flight Research Center. There were also opportunities for the curious crowd of several hundred people to learn more about the capabilities of the Red Planet's newest rover through exhibits set up by Dryden. About 7,000 Bay Area space fans came out to the Ames Research Center early to grab a good spot on the lawn to watch NASA Television's coverage of Curiosity's landing later that night on giant screens. There was plenty to keep them busy in the meantime, including hands-on activities and displays, plenty of food trucks, and more. Ames scientists were on hand to answer questions about the mission, and presentations were given by Center Director Pete Worden and other Ames researchers about the role of Ames in support of the MSL mission. Later that night, when the good news from Curiosity reached Earth, the crowd at Ames joined the JPL team in celebration.
It may have been early on the East Coast, but the visitor center at Goddard Space Flight Center was bursting with excitement as 350 people anxiously awaited to hear that the Mars rover Curiosity had landed safely on the red planet. The crowd erupted into cheers when word came down from Jet Propulsion Lab's control room that the rover was up and running on the Martian soil. In addition to watching the landing live, visitors also heard from scientists about the mission and specifically about Goddard's role in building SAM, or Sample Analysis at Mars. It's one of the instruments on board Curiosity that will be testing the soil and atmosphere for the building blocks of life. Visitors also had the opportunity to explore the visitor center, which included testing out an interactive video game that allows players to take their best shot at landing a rover on Mars.
At the Virginia Air and Space Center, the official visitor center at NASA Langley, about 250 people showed up for Mars Midnight Madness. The overnight event included Mars-related exhibits and information for those curious about the Mars Science Laboratory. As the time for the scheduled landing of Curiosity approached, people filed into the center's IMAX theater to catch the historic event on the big screen. The successful touchdown, an especially proud moment for Langley, whose contributions to the mission included the MSL Entry, Descent, and Landing Instrumentation, or MEDLEY, a group of 14 sensors in the heat shield used to monitor temperature and pressure during Curiosity's descent through the Martian atmosphere. The Glenn Research Center held several MSL Curiosity events in the Cleveland, Ohio area. On August 3rd, a group of the agency's social media fans were treated to a tour of several research facilities in the morning and participated in a multi-center NASA social hosted by JPL in the afternoon. 2 days later,
hello, welcome, we are the world-famous rockin' robots.
The center held a Spark Your Curiosity event at the Cleveland Museum of Natural History that featured discussions with Glenn subject matter experts and interactive activities. Later that evening, Summer of Innovation students participated in activities at the Great Lakes Science Center, Glenn's official visitor center.
We just succeeded one more time in raising the bar even higher. New technologies never invented or attempted before were created for this incredible journey.
With the harrowing descent through the Martian atmosphere in the past, the team of engineers and scientists working with Curiosity has turned its attention to the mission ahead, exploring the surface of the red planet for clues about the existence of life. Shortly after its landing, the rover began beaming back images taken by its Hazard Avoidance Cameras, or HAZCAMs. Higher resolution images will be used during future operations by the mission's navigators to help plan Curiosity's path of exploration as it sets out on a nearly 2-year prime mission to investigate whether the region ever offered conditions favorable for microbial life.
We've collected data across the entire Gale Crater and the landing ellipse, and we've got stereo data and color imagery that have already been used to start looking at potential traverses.
We'd like to know definitively what minerals are in that soil. And so by analyzing it, we can get a better understanding of what the composition of the soil is, certainly where we've landed, and by inference maybe also globally, and through that get at one of the most global questions we could address.
Curiosity undergoes the most difficult planetary exploration mission ever conducted. It is enabled by a suite of 10 science instruments with a total mass 15 times as large as the science payloads on the Mars rovers Spirit and Opportunity. Some tools are the first of their kind on Mars, such as a laser to check the elemental composition of rocks from a distance. Curiosity will also use a drill and scoop at the end of its robotic arm to gather soil and powdered samples of rock interiors, which can then be sifted and parceled out to analytical laboratory instruments inside the rover.
With the spacecraft being as healthy as it is and the capability that it has, all our options are open for science.
Out at Edwards Air Force Base near the Dryden Flight Research Center, the remotely piloted X-48C aircraft successfully got its first flight under its aeronautical belt. The X-48C is an X-48B blended wing body aircraft that's been modified to evaluate the low speed, stability, and control of a low noise version of a possible future hybrid wing body design. The HWB design stems from NASA's N+2 Future Concepts studies under the agency's Environmentally Responsible Aviation Project. Hey, got a minute? That's how long the latest test firing of the J2X engine took at Stennis Space Center, as NASA continues development of the Space Launch System, America's next heavy-lift rocket that will carry humans deeper into space than ever before. The 60-second firing operated the engine at the primary and secondary levels in an effort to collect more data about the developmental engine. The J2X engine is being built by Pratt & Whitney Rocketdyne for Marshall Space Flight Center. The Kennedy Space Center has been Googled. In celebration of the center's 50th anniversary, KSC and Google Maps with Street View are providing space enthusiasts with virtual tours of the cavernous Vehicle Assembly Building, Launch Pad 39A, and other unique facilities used to help launch humans to the moon and space shuttles to low Earth orbit. Earlier this year, a crew of 5 Google Street View personnel spent a week at the center collecting data and imagery. NASA's 3 space shuttles were still at Kennedy, so don't be surprised to see Atlantis and Endeavour in the Vehicle Assembly Building. To take the tour, go to Google Maps, navigate to Kennedy Space Center, and then switch to Street View.
The radiation belts are the first and perhaps the oldest discovery of the space age, yet they remain a mystery simply because this is a very harsh environment.
Scientists and project managers discussed the upcoming mission of the Radiation Belt Storm Probes, a NASA twin spacecraft designed to study the extremes of space weather by studying the planet's Van Allen radiation belts on various scales of space and time.
We have broadcasting, both satellites, 24/7 space weather. This is going to get picked up by ground stations around the world.
Scheduled to begin with a pre-dawn launch August 23rd from the Kennedy Space Center, RBSP is part of NASA's Living with a Star program, which investigates the processes of hazardous space weather and its effect on space exploration.
Enthusiastic teachers from around the country recently gathered at NASA's Dryden Aircraft Operations Facility in Palmdale, California, to participate in NASA's Airborne Research Experiences for Educators and Students, or ARES. For 2 weeks, the educators focused on NASA's Earth science programs and flight research missions. In the first week, a dozen elementary and high school teachers discovered how to find NASA educational resources, learned about aircraft used for Earth observation and data collection, and discovered how engineers integrate specialized science instruments into aircraft for observing and monitoring terrestrial changes. An additional 14 educators from NASA's Explorer Schools program joined the ARES participants during the second week to participate in a simulated NASA ER-2 Earth science mission. The teachers compared imagery and data collected by science instruments from previous airborne missions to ground data and imagery obtained during a field site visit in Central California. Middle school science teacher Michael Octatai expressed confidence that the training, speakers, materials, and hands-on activities will give ARES attendees the tools to create effective education action plans.
We're able to actually look at abstract ideas and concepts that are normally on paper, and we actually had the opportunity to travel to different sites, actually conduct some research and do some hands-on experimentation.
35 years ago, on August 12, 1977, Enterprise, NASA's first space shuttle, experienced its first free flight at Edwards Air Force Base near Dryden Flight Research Center in California. This was one of 5 flight evaluations conducted at Edwards as part of the Space Shuttle Approach and Landing Test Program, jointly managed by the Johnson Space Center and Dryden. Enterprise had previously completed 8 captive carry flights, anchored on the back of a modified Boeing 747 Shuttle Carrier Aircraft, or SCA. These captive flights verified the orbiter systems and cleared the way for the shuttle's first free flight. On board Enterprise were astronauts Fred Hayes and Gordon Fullerton. Though Enterprise never flew in space, it proved the Space Shuttle orbiter could fly in the atmosphere and land like an unpowered glider. The famed orbiter recently went on public display at the Intrepid Sea, Air and Space Museum in New York City. And 50 years ago, between August 11th and 15th in 1962, the missions of the Soviet Vostok 3 and Vostok 4 spacecraft marked the first time that more than one manned spacecraft was in orbit at the same time. The cosmonauts aboard the 2 capsules, Andrei Nikolaev in Vostok 3 and Pavel Popovich in Vostok 4, also participated in the first ship-to-ship communications in space by contacting each other via radio. And that's this week at NASA. For more on these and other stories, or to follow us on Facebook, Twitter, and other social media, log on to www.nasa.gov.